is not executed on Ethereum. So there is no gas fees per se. However, this is on Impula network. It is not open for the public at large. This is a private ledger, and this works on a number of parameters which are very important, and that is under the regulation of the international laws. Now, I will walk you through some of the applications of the same and how the protocols are being deployed globally in terms of the generative technologies. So I'm putting myself on mute and we will start in a while. I have already fetched the data. We'll just go deep diving. Okay, so first of all, we are going to talk about the understanding of the tagging part because it's very important from the framework of the protocols when we're talking about the generative technologies. First of all, one of the most important tag is around receiving the signal strength. How the signal strength is received in the best possible manner. So this can be one of the subsets, that is H04B17/318. Now, when we are looking at the signals, we need to understand what are the active lenses and what is the reflective array around the same. That is H01Q3/46. For support vector machines, we have, so support vector machines is SVM, that is G0 6N20/10 machine learning using kernel methods. When we are talking about the convolution networks, it's G0 6N3/0464. Combination of networks is G0 6N3 slash 045. Now learning methods. This is something I have been focusing on for quite a while on the Impula network for different stakeholders to understand the protocol in terms of the civil society and the others. So here, this is, if I'd have to emphasize on the compressed networks, is G0 6N3 slash 04595. This is compressed networks, quantized network, and for the learning methods, we have G0 6N3 slash 08. For modifying the architecture, that is adding, deleting, slicing, or silencing the nodes or the connection, is G0 6N3 slash 082. Supervised learning. So there's a difference between transfer learning and supervised learning. Transfer learning is G0 6N slash 096. Supervised learning is G0 6N3 slash 09. Non-supervised learning, that is competitive learning. That is, I would say it's kind of a hackathon when we're talking about the competitive learning. G0 6N3 slash 088. One of my favorites, I have worked a lot on this. That is MIMO system. MIMO is multiple input, multiple output. So there's MIMO and NEMO system. When we talk about MIMO system, that is the cooperative use of antennas of several sites. Example, in coordinated multi-point or cooperative MIMO system, that is H04B7 slash 024. Okay, now, here when we talk about V2P, that is vehicle to pedestrian, for communication between vehicles and infrastructures, example, vehicle to cloud, that is V2C, or vehicle to home, that is V2H. These are utilized for particular environments, that is H04W4 slash 44. Machine type communication is MTC, and we have M2M, that is machine to machine communication. Here we can deploy intranet to H04W4 slash 70. Then we have the protocols, or protocol in which applications distributed across the node in the network, that is H04L67 slash 10. We have H04L67 slash 12 for proprietary and special purpose networking environments. Example could be the medical network, sensor network, network in vehicles or carriages, or remote metering network. So this is done. Okay, let's understand this. So we are deploying the smart contracts on the Impula network, and we have already identified the hotspots. So these are multiple hotspot units, and that is also only uh, the utilization of the same is for only few candidates of the system. Not everybody can be utilizing the hotspot. And then we obviously have the firewalls just to have the privacy in place. So for that, we have the routers and stuff. If I have to deep dive, so I'll be taking you through the 73 gigahertz understanding as to how it can be utilized, and particularly try and understand AIPN, that is nano-tech, and the cloud computing around the same. So, okay, interesting. Okay, this is done. Okay. So, in daily life, what are the tech which are being utilized at mass is Bluetooth, Wi-Fi, and the like. And we already know 5G is the uh, short form of fifth generative technologies, and it is it is using the handheld devices with larger bandwidth. It is made possible, and it is covering through wide area using a quite high throughput. Um, what is important here is to understand um how much Mbps is at full mobility, and what is the stuff around the low mobility. So I'm not getting into the smart antenna techniques right now. I'll just walk you through something which is interesting to me. Here we are talking about the low latency and the high latency. Particularly the cell walls we already talked about. Okay, this is funny, all these questions. Best dipping sauce ever. Anything to do with chilies. Okay, next. We were at MIMO. Analyzing thread protocol, distributed ledger. So RAN stands for Radio Access Network, or a remote RAN can be deployed. Not interested for the Impula stuff. I'm just seeing what we can deploy on the Impula stuff and understand from the. Okay. Okay. So we'll talk about beamforming actuator driven active antenna to track the moving stuff, that is communicating data with the UE using an array antenna on board a cell tower and having digital beamformer, that is DBF, and we have radio frequency radiating elements. If I have to walk around this, it would be okay. So you have to look into the application which I had drafted for UWB. A lot of work has been done, so look into that. Then there is a common public radio interface, that is CPRI. Then we have OBSAI, Open Base Station Architectural Initiative. Then we have Open Radio Interface, that is ORI. This is done. Oh my gosh. Okay. Yes, we also have to look into the software defining networking, that is SDN. Then we have NFV, that is network function virtualization, and look into the impact with the UWB. You will be able to understand better. Yes, we did work on URLLC, that is ultra reliable low latency communication. It is associated with 5G, but it can be deployed for 6G, 7G, and the like. So there's something called as PDCCH, Physical Downlink Control Channel. So protocol data unit is PDU. Okay, there's a lot of support here. If I have to just break it down, okay, let's see this one. We'll understand the blockchain cellular system of one of the applications here, and I'll just wind it up in a while. And then perhaps I want to discuss about a little bit of the pharma stuff, maybe in the next video. I need to discuss the pharma stuff. I need to discuss something around the food technology stuff. So that's the agenda for today. Okay, blockchain cellular system. Why do I see the same stuff again? Okay, let's see this. Okay, for building energy consumption, so we already talked about energy exchange in last couple of videos. And what is important here is whatever the heat which is being dissipated by these devices, handheld devices, or the apparatus, or the machines, that has to be in sync with others in terms of that energy has to be utilized to drive the system. And here I'm talking about not utilizing the current. So neither we are using the direct current or the alternative current. So neither DC nor the AC, but the other technology which is on the Impula network. So you have to look into that aspect also. Okay, let's. Should I go with the intelligent health monitoring? I'm just trying to figure out before I talk about it. This was in 18. This is in 20. Okay. Or perhaps let's go with something which is very recent, filed in 2025. So it's environmental, taking into account the environment sensing protocols. So we have the classification techniques G0 6F18/24, G0 6F18/21, design or set of recognition systems or techniques, extraction of features in feature space, and blind source separation, which is good. Fusion techniques of extracted features G0 6F18/253. Hopfield networks characterized by memory or gating, example LSTM, that is long short term memory. And we have gated recurrent units, that is GRU. Transfer learning, good enough. Let's see what it is up to in terms of. Okay, let's understand this. So we will first understand the background of the same, and then we'll try and figure out what are they disclosing per se, because I feel it's more of a trade secret rather than the disclosure here. But let's try and understand. Okay, so generally, in most of the houses, homes, um, where there is some kind of habitation happening, at least in other countries, not particularly in India, you have a homostat and it is checking the temperature in one room. It knows to turn the heat on or turn the heat off. Not very smart, but very simple logic has been applied there. It never learns about when the sun hits the living room windows at whatever the time duration is. Neither it is letting know the other parameters which might be important in terms of describing the generative technologies of the 6G, 7G, and the like. So, how to make this whole stuff smart? So the old way is, or the new way is, there is GPS, there is that is global positioning stuff, latitude and longitude, and then it remembers everything in the fastest, cheapest, and the most comfortable time zones. All the major time zones are already captured, and it is activated at a time when the time zone is deployed in the application, and the time is predefined, so it's just activated at that point of time in terms of the switch is switched on and then the switch is killed at the same point of time. So this happens. Now what are they doing? So it's a real-time monitoring method of the environmental perception and the energy consumption. So it is kind of creating an adaptive matrix. So let's look into this. Okay, so this to happen in reality, we need to have these self-learning models, which is kind of a AI layer. AI is the artificial intelligence layer, but the library of data sets is taken from the books which are already there, and that gives some kind of factual data. Honestly speaking, even the books which are written maybe at any point dated back to whatever the uh, timeline we are going back. It might be right, it might be wrong, it might be neutral, or perhaps it is fiction altogether. So we need to figure out whether it's fiction at the first instance or not. Now, um, so it's like developing a super brain. Have a nickname. I refute to answer that question. I have loads of nicknames. Okay. So this is the question asked by this uh, YouTube at the back end. Honestly speaking, I don't know whether an admin is doing it or it is learning of the AI part. Anyhow, so the point here is we are talking about a super brain, which is looking into the environmental data, sees everything, learns the unique personality of the building itself. Okay, somebody said hi. Hi. So it is predicting instead of reacting. So what happens is when we have the prediction beforehand, a lot can be mitigated when you are deploying the SWOT in the real time, and that has to be trained with the small language models. It is able to determine the faults before they become expensive. Prevention is better than cure, so that's the analogy one has to understand here, and it keeps everyone comfortable in terms of when we are deploying it in a building. Perhaps it can be an office building, and moreover you are going to see this in office building or in hospitality industry because it's very evident. So So here, if I have to talk about the system analytics, we have a tiny adaptive controller that keeps comparing the predictive versus the measured parameters and nudges the hardware. So the I would say the industry is not drifting away from the optimum. And what is important here is to have the prediction model ready for analogy. I would say for the analogy, it's good. And another one is anomaly detector because the anomalies are predicted beforehand. And that is basically to do with the drill. The same way we do the cyber drills, in a similar fashion, when we are developing anything which is smart, creating that super brain out of the data which is being logged in, and a lot of hypothesis has to go into it at any given point of time on the Impula network for describing the possibilities and the probabilities. And since we don't have Ethereum here, the smart contract still happens because this is disclosed in a very private leisure kind of distributed system, and this is part of the whole nexus of the way the new world is supposed to work, and that kind of data set is already very evident from the agenda items of different organizations, different stakeholders. It's just that there's so much discussion right now without even understanding the protocols. So the need of the hour is to have the basic understanding first and then developing the protocols around the same. Thank you for watching this out, and yes, keep pouring the DMs. I have some submissions to make, so hopefully I'll work on it, but I'm not very sure how much to disclose, so because this is more of a trade secret project, but good enough to be deployed on a global scale. Thank you for watching this out. Have a great day ahead.